Hello everyone, welcome back to a new video of this section of my channel entitled How to Start With. On this occasion, the Arduino Micro. And yes, you heard well, the Arduino Micro instead of the Arduino Pro Micro. The last one is supported by links, but this one is not supported. So how on earth are we going to make it work with LabVIEW? So we are going to create our own firmware. We are going to install it here, and then we are going to read the temperature from a LM35. Let's start it. As usual in my videos, you can navigate through them. In this video, apart from this introduction, section 1, in section 2, I'm going to cover the most relevant technical features of the Arduino Micro, with a special interest in the analog to digital converter and also the GPIO port. In section 3, I'm going to comment the firmware that I'm going to install in the Arduino Micro in order to make a communication with LabVIEW. Very briefly, I will go into Measurement Automation Explorer and I'm going to explain what is the minimum setup that you have to carry out. Finally, in section 4, the thing that I'm going to do is to implement a program where I'm going to measure the temperature that is going to be given by a LM35. Without further ado, let's go. Right, here we have the Arduino Micro. As you can see, fits perfectly in a breadboard. The only point is so small that it's difficult to read the name of each line of port. Because of that, I'm going to use this schematic that I have here that it's represent the pinout of this device. I'm going to focus on the analog to digital converter. The number of bits of this converter is 10 bits, which resolution is not very good compared to another microcontrollers. Then the sampling rate is 10 kilo sample per second. So it means that you can acquire signal up to 1 kilohertz. The range, input range, goes from 0 to 5. That is good, acceptable. And the feature that I like a lot, okay, the most from the Arduino family is the pin that the internal voltage reference of the device, okay, can be modified. There is an external pin that is a ref, but also you have an internal reference that is 1.1. And if you are measuring things between 0 and 1.1, the resolution is going to increase, is going to be better, and is going to increase in almost 5 times. Another important feature, how many channels? So you have a multiplexer, and in total you have 6 channels in this side, okay, from 0 to 5, and then in the other side you have also scattered some other pins. So in this side and another, very nice, depending on the placement of you have your sensor, you can take from one side to another. That is something good. Watch out with the pins of whatever microcontroller, compact one like that, because pins are not fully dedicated. So be sure that you are using in your application that pins only for that purpose. Otherwise, the application can crash. The GPIO port of the Arduino Micro has an overall number of 20 pins. That pins are going to be numbered from the D0 that you have here till the D13 that is in the other side of the board. In addition, you can also use channels from the analog to digital converter, those ones which go from A0 till A5. So in total you have 20 pins. These pins work under a CMOS logic level, which means that the high level is 5 volt and low level is going to be 0 volt. In terms of current, these terminals are capable of providing a nominal current of 20 milliamps and a maximum one of 40 milliamps. You have to keep in mind that in your application, the maximum current that you can extract from the Arduino Micro is 200 milliamps. Besides, among these 20 terminals, there are 7 of them which are capable of generating PWM signals. These terminals are marked in the schematic with a red cross. Last but not least, I have to say that the Arduino Micro has the USB protocol natively implemented. That means that even when you connect it to the computer, okay, by the USB cable, the pins named here as TX and RX are free and you can use them for whatever purpose. Section 3 of this video, which is related to the software. To settle things down, the piece of software that we are going to need is first, we need some kind of driver in order to establish a communication via LabVIEW through the USB port and the serial port. That is going to be done by NI package management, and the software that we are going to need is Visa. Then second, we need to install the environment by Arduino in order to upload inside the Arduino Micro the firmware. Third, the thing that I'm going to do is to open this firmware, command the most relevant feature of this firmware, and upload it. So step by step, first of all, NI package management, and the thing that we are going to do is to install Visa. So NI Visa is the driver, is very generic driver, very useful. Here it is, okay. In my case, I have already installed it, okay. If it is not the case in your computer, here is going to appear install. So click install, and then the next, taking all the default options. And I have to say that this is going to take some time, okay. So let's move into the next section, okay? All right, the second part, or the second piece of software that we need, is the environment in order to program the Arduino Micro. The software that we are going to use is the free one that is going to be distributed by Arduino. So we will go to its webpage, which is this one that we have here, and then I will go into product, and then Arduino IDE. In Arduino IDE, now I have to select what is my operating system. If you are using Windows, I recommend you to take the second option, then download, install it, next, take the default configuration, and done. As a rule of thumb, all the time that we want to connect something to our computer, we should open the device management in Windows. So in our case, the thing that we are going to do now is to connect and verify that the device is present. Here it is, and if you go to ports, okay, here it is with the COM11. Okay, so now it's time to move into Measurement and Automation Explorer. Here we are right now in the Measurement and Automation Explorer. The Arduino Micro is already connected there to my USB cable, and the thing that I'm going to do is to roll down devices and interfaces. The Arduino Micro should be attached to COM11, so it's here. All right, the thing that I'm going to do is to give a different nickname, and it's going to be Arduino Micro. All right, we are going to save. Only one thing left, that I had a lot of problems in the past related with this configuration of Visa. Check these things. So NI Visa, Visa option, and then go to passport and verify that the tulip is not marked. Okay, tulip is the driver that is needed, or passport that is needed in order to make work converters from GPAV to USB. If you have one of them, you should have this one marked. So remember, to disable in case that you have this one checked. So right now, save, everything done. Let's go now to LabVIEW and implement our application. Right, the moment that everybody is waiting for, when I have to command the firmware that I'm going to upload into the Arduino Micro. Here I have this firmware. The link to download this firmware is available on the description of this video. I have opened it with the IDE by Arduino, and basically, in general, the thing that I have to say, from LabVIEW, I'm going to send 2 characters, ASCII character, that is going to be A, to indicate that I want to make a conversion with the analog to digital converter, and then a number. The number is going to identify what channel I want to read. So first I'm going to define this command that is going to indicate that conversion. Then in the setup, the thing that I'm going to do is to initialize the serial port, and I'm going to wait till the serial port is ready. Main loop. With this instruction, I'm going to wait till I have something in the serial port. Once I have something, I expect two ASCII character. The first ASCII character is going to be stored in B1, and the second one is going to be stored in B2. Of course, B1 is going to be, I'm going to check if the B1, okay, is equal to A. That is the command that indicates that I'm going to make the conversion. Then the B2, so several options. If it is 0, channel 0. If it is 1, channel 1. Otherwise, it's going to be channel 2. Then, here is the place where I'm going to make the conversion. And look that I will not bother about any kind of conversion into voltage, okay? So this is something that I will do in LabVIEW. Finally, this value that I got, I'm going to send through the serial port. And watch out here, very important, that at the end of this value that I sent, I'm going to introduce an intro. That intro is going to be checked by LabVIEW, and it's going to indicate that the communication is open. All right, so that is the whole firmware. The thing that I'm going to do now is to, here I have my Arduino Micro, and I'm going to upload that sketch. And uploading, and done. So everything done now. So it is a moment to go into LabVIEW and prepare the application. Right, here we are in LabVIEW. As usual, I have created my own project, and inside that project, I have also created a VI. That VI with the name of index. Okay, you can download all this project, and the link is available in the description of this video. I will not extend too much in the explanation of this VI. Okay, so mainly here we have the block diagram, and here we have the front panel. All right, so as usual, I have a while loop that is going to repeat over and over till you press the stop, or you have some kind of error through the error line of the serial port. That part here is going to execute only once. And the first thing that I'm going to do is to define the visa port characteristic. And the most relevant thing is to say that you are going to define a termination character that is going to be a new line. New line in ASCII, it's 10, okay? And that is the reason why you have here 10. Then another important thing, it's the event, okay? So this visa enable event that is going to define what is the event that is going to move, okay? The communication. That is going to be a character. So the thing that we expect in the channel is a character. Then we have to wait here 2 seconds in order to transfer all of that to the Arduino Micro. Okay, by the way, the Arduino Micro, it's here. And here we have the LM35, which is connected, the data of this sensor is connected to the channel number 1. Okay, so once in the main loop, the thing that we have here, it's this visa that is going to flux. I'm going to clean all the buffer that I have in the port, and then the thing that I'm going to do is to send a command. That command that I'm going to send is the A, okay, plus the number of the channel, because I have connected it, okay, to the number 1. I'm going to put here number 1. By the way, this one that I have here, I didn't comment. This is the visa resource name, okay, and I have also to define it. And if I roll down, voila, here I have the Arduino Micro that I defined in the Measurement and Automation Explorer. All right, getting back here. So I wait 50 seconds to send the command. And now, again, the thing that I'm going to do here is to wait. Okay, wait till I have something in the channel. After that, the thing that I'm going to do is to read once I have something, okay, and that thing that I'm going to do is the conversion, the result of the conversion. That is going to be a string, an integer, but the characteristic is going to be a string, so I have to convert it into number. And now with that operation, the thing that I'm going to do is to multiply by the resolution. That resolution is 5 divided 2 power 10, and you have to understand that after this multiplication here, okay, I don't know if you see here, okay, is going to have, the thing that you are going to have is volts, okay? Now I'm going to multiply by 100, that is the conversion, the constant that is going to convert from volt into temperature. That is something characteristic from the LM. And done. Everything done. Very important. Last part here that you need to, okay, arrive to this part of the program where you are going to close, okay. You are going to close the communication and you are going to release all the resources that you booked. To do so, you have to click here in the stop, okay, instead, okay, of clicking here about execution. Otherwise, you are going to receive error, and in the worst scenario, you can keep the port engaged, okay? And it's going to be very difficult to reestablish the communication. All right. So the thing that you have to do is to reset that one, and sometimes even you have to close the whole LabVIEW. So now it's the moment, okay, to make it work, and I'm going to run here. And here it is, okay. So here we have the temperature, so it's 20 Celsius degrees, and now I'm going to touch the sensor. I hope not to have cold hands. Right, good. So it is work, okay. And finally, the thing that I want to comment is the refresh. So the time that is going to take to refresh this data, and here I include a delay. So it's that delay, if you add all the delays that you have here, the measurement is going to be refreshed almost each half second. Right, so that's all from my part. I hope that you enjoyed this video, and I hope that could be useful for you, and I hope also to see you soon. Till next time, bye bye.